Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
For this question, we're trying to determine how far the bungee jumper is above the water when he reaches the lowest point in his fall. Well, at the lowest point, assuming energy is conserved in this system, at the lowest point, we have fully potential energy from the spring or from the bungee cord about to propel the jumper back up. That has to be equal to the original potential energy we had in the system before the bungee jumper jumped, which is the potential energy due to gravity, right? If energy is conserved in the end, since he has no velocity right at that maximum point, he's all potential. And at the beginning, before he's jumped, he has no velocity. It's all potential. So the potential energy final is potential energy initial. Well, the initial potential energy is mass times gravity times the height of the object. The final potential energy is 1/2 k x squared. So what we want to do is we want to solve for x. So what we have is x is equal to the square root of 2mgh divided by k. But what we want to know, that's x. That's the amount the bungee cord stretches, okay? What we want to know is what is the height, or x prime. So x prime is going to be equal to the original height, h. So what we have, if we look over here, the gentleman jumps down, and this is the maximum point he reaches. X is the maximum stretch from the equilibrium point here, where the equilibrium point is 1/2 the length of the full length of the string, or the spring. That's the equilibrium point. So x is the amount stretched beyond that halfway point. So what we have here, if this is, let's say, this is the halfway point, x stretches more than the length of the spring. So the full length, let's call it L naught, is going to be the amount. This would be to here. Then this amount, if he stretches that amount, is going to be the x amount. So let's say there's a person hanging upside down here. So he would look maybe something like, here's his legs, here's his body, and his head, like this. Well, he still has maybe a little bit to go because the full length is the height, the total height. So we want to take that height and subtract it from that height, the original length of the rope or nylon, L naught, plus x, because that's the new length. So doing that, we find that the x prime value is equal to 10.1 meters. And we can box that in as the solution to our question.